Hey guys, I'm back with another video. Today's going to be lesson number 4. We're going to be solving problems with trig. Alright, but before we get into that, let's take a look at these two problems I selected from the homework that a lot of people had trouble with. Alright, so this first one. Oh man, this first one. Only a select few people got this first one correct. Alright, and you had access to your notes, to all internet resources. You had 2 days to do this. And I think only 4 people that submitted so far got this one correct. So let's take a look. Alright, in right triangle ABC with a right angle C, sine of A is equal to that and cosine of B is equal to that. Determine and state the value of x. Alright, I'm going to draw out my right triangle. Right angle at C. So I know A and B are the acute angles. Alright, sine of A is equal to 2x plus 0.1. Well, let's set it up as a ratio. Sine of angle A. If this is angle A, right, the opposite side should be side A. So that's going to be side A. It will be a length of C. And that length will have that side will have a length of C. Alright, so sine of A is going to equal A over B in this ratio. Right, and cosine of B is also going to equal, I always do that, I don't know why I keep doing that. It's going to equal opposite over hypotenuse, which is A over C. And cosine of B is going to equal adjacent over hypotenuse, which is, again, A over C. So we know sine of A is equal to cosine of B. Yeah, because A and B are complementary angles, right? And we know the sine of an angle is equal to the cosine of its complement. So over here we know that sine of A is equal to cosine of B. And if you didn't know that, this is kind of what we proved yesterday, right, by looking at it. And so if sine of A is equal to cosine of B, well, then 2x plus 0.1 equals 4x minus 0.7. And all we have to do now is solve for x. So we get 2x equals 0.8. X equals 0.4. And that is it. You set them equal to each other and you solve for x. Alright, so what was everyone doing then? Well, this is what most people did. They added the two values together and made that equal to 90. Alright, that doesn't make any sense because we know the angles add up to 90. Angle A and angle B, those are the angles, right? A plus B equals 90. Right? When the angles are complementary, then the values of sine of those complementary angles are equal to each other. Right? The values of sine of A and cosine of the complementary angle to A, which in this case is B, those are equivalent when the angles are complementary. So a lot of you were doing this when that didn't make any sense. And I think the reason you were doing that is because if you looked at the example I did over here, right, that's what I did. I set the two angles equal to 90, adding them up. Right? But this question is completely different. This question is asking if sine of 2x plus 4 equals cosine of 4x minus 7, then what does the value of x have to be? I'm taking the sine of some angle and the cosine of another angle. Right? I know sine will equal cosine when the angles are complementary. So sine of A equals cosine of B if angles A and B are complementary. So in this case, I add up the two angles and I set them equal to 90. Alright? In the homework, I already know the angles are complementary. So because the angles are complementary, the values of sine and cosine are going to be equivalent. So you set them equal to each other in this case. Right? And that's the difference. So this here is a big no-no. And that is what pretty much everyone did. Alright, and the next question is, in the diagram below, these two triangles are similar. Which statement is always true? Alright, so looking at the way they named this, angle E corresponds with angle J. So that means I know angle E and J are congruent, T and R are congruent, right? Because in similar triangles, corresponding angles are congruent. Right, so which statement is always true? So is cosine of J equal to Rm over Re? Well, I know cosine of J is equal to adjacent. So I'm looking at angle J here. The adjacent side will be Jm over the hypotenuse, which is Jt. So I do not see that as a choice here. I see cosine of R is J over Jt. And that's obviously not going to be true because cosine of R that's the adjacent, that's the hypotenuse. So I can eliminate choice 2. But is cosine of J equal to Rm over Re? Well, cosine of J is also going to equal cosine of E because J and E are congruent angles. So cosine of E would equal adjacent, which is ME, over the hypotenuse, which is RE. And that is not what is written here, so that is incorrect. Right? But this would also equal cosine of J. And that's because, again, J is equal to E. Alright, so now we have to check these two. If you check 3, it doesn't work out. So let's go straight down to tangent of E. Tan of E is going to equal, erase. Let's take a look. Tangent of E, SOHCAHTOA, that's opposite, in this case Rm, over adjacent, which is ME. So tangent of E, we have Tm over Jm, so let's see. E again is congruent to J, so let's see what tangent of J is equal to. That's opposite. Now we're looking at the smaller triangle, so opposite is just Tm over adjacent, which will be this side length, right? And that's Jm. And that is what choice 4 says, so this one was choice 4. Alright, so yesterday's homework, I asked you to fill out the values for 30, 45, and 60 degrees for sine and cosine. But let's take a closer look and let's get in general. There are 2 other special trig values you should know, which are sine of 0, cosine of 0, and sine and cosine of 90 degrees. So let's see if we can figure what those are. So taking a look at this diagram, what is happening to A and B as data changes? So for the sake of keeping our triangles consistent, here is a circle of some radius, right? The radius here is C. And so let's start with a very, very, very small angle. Maybe that's like 5 degrees or 2 degrees or something. But looking at this very small triangle here, right? My opposite side is going to be this guy. Let's call it A, right? And my adjacent side is going to be B. So right now, when the data is very small, right, my angle A is very small, but my side length A is very big. Okay, I'm sorry. When data is very small, when an angle data is very small, right, this value of A is also very small, and this value of B is quite big in comparison, right? As I increase data, right, you'll notice this height of the right triangle is increasing, right? And that height is going to correspond to the value of B, the value of A. And this distance of B, that's decreasing. So as I keep going, you'll notice A is still increasing. It's getting bigger. Right, over here we have this triangle, and bigger, until it's getting bigger and bigger, until it's almost vertical, right? And when my angle now is very big, let's say, let me draw out a proper right triangle. Right, when my angle data is very close to 90 degrees, right? Let's say this is like 89 degrees, for example. So when you see this angle is very big, like 89 degrees, getting close to 90 degrees, our value of A, well, that's really close to being the same thing as the value of C, which is the radius, right? And you can also see that our value of B has shrunk to be very, very small, right? And can you guys see as we get closer and closer to 90 degrees, the bigger and bigger this value of A is going to become, and the smaller and smaller this value of B is going to become, right? I can always just increase the angle. It's going to get more and more vertical, this hypotenuse. And A just gets a tiny bit bigger, and B just gets a tiny bit smaller, and that keeps happening. All right, so to answer this first question, what is happening to A and B as data changes, we can say as data increases from 0 to 90 degrees, right, this value of A increases, and this value of B decreases. All right, so hopefully that makes sense. Let me just draw two triangles to show the comparison. Right, here's a small angle data. A is small, it's getting bigger as data increases, and if I make data even bigger, right, A gets bigger. And at the same time, we can see this value of B here, quite large. As data increases, it gets a little smaller. And as data increases again, it gets smaller. Right, and the hypotenuse, by the way, is always the same, right? That's staying C, a constant, because when I draw my triangles, that's always the radius of the circle. All right, so as we go from 0 to 90 degrees, what's happening to sine data and cosine data? Well, sine data is opposite over hypotenuse. So when our data value is very small, right, this A value is going to be very small, and we're still going to be dividing by C. But the closer and closer we get to 0 degrees, you guys agree that the smaller and smaller this value of A is. So as we approach 0 degrees, well, A is getting closer and closer and closer to 0, right? At 0 degrees, we obviously can't draw a triangle. It would just be a flat horizontal line, right? So if you imagine the height of this triangle, that would be A. There is no height. The height is 0. So therefore, sine of 0 degrees is 0, right? And as we increase the angle data, what's happening is this A value keeps increasing, right? But our hypotenuse stays the same. And sine of data is always going to be A over C, right? Opposite of hypotenuse. But that hypotenuse is always staying at a value of C. So as A is increasing, well, the value of this fraction is going to increase. So as data increases, this value of A increases, but C stays the same, right? It stays the same value. So therefore, as data increases from 0 to 90 degrees, we can also say that the value of sine data increases. And what's going to happen to the value of cosine data? Well, cosine data is the B value. So the B value starts out really, really big. And as we keep going, though, that B value keeps decreasing, right? And we know cosine of data in this instance will always be adjacent. The adjacent side in any of these triangles is the length B, right, over the hypotenuse C. So as data increases, our B value decreases and our C value stays the same. So the value of cosine data decreases. Right, so it's pretty much just saying the ratio of A to C is increasing, right? Sine data is increasing. That ratio A to C is increasing as we increase our angle. The ratio of B to C is decreasing. Cosine data is decreasing, right, as we increase this angle data from 0 to 90 degrees. All right, so you're going to need a calculator. So grab your calculator, and using your calculator, calculate these trig values. So you're going to type in sine of 0, sine of 10, sine of 20, sine of 30. All right, just got some practice doing it, and we're going to round everything to the thousandths place, 3 decimal places. And before we do it, let's also talk about sine of 90. So at 0 degrees, we were a horizontal line, right? But at 90 degrees, we're going to be pretty much a vertical line. So let me just draw something very close to vertical, like that. All right, so opposite, if this is our angle, theta down here, right, opposite will be A, and the hypotenuse is C. Do you see how A is getting closer and closer to the value of C, right? Until when it's vertical, the A value and C value are going to be pretty much exactly the same. Well, at 90 degrees, they will be the same, even though you can't draw a triangle. And if A and C are the same, A over C is going to equal 1. So sine of 90 degrees is going to equal 1. All right, so take a second, type in these values, and bam, this is what you should get. All right, so this is just giving the actual numbers to what we were talking about. As our angle increases 10 to 20 to 30 to 40, do you see how the value of sine data is increasing? Right, it's going up and up and up and up. Right, sine of 30 degrees, this is one we should know from our special right triangles. Right, at 30 degrees, boom, this ratio, that's in a 1 to 2 ratio. Right, this A value is exactly half of C, or the C value is twice of A at 30 degrees. And then we keep increasing until sine of 90 is going to equal 1. So actually, once we complete this table for sine of theta, well, we know because sine and cosine are cofunctions that if sine of 90 degrees is 1, the complementary angle to 90 degrees is 0 degrees, so cosine of 0 also must be 1. And again, let's take a look to see if this makes sense. If I draw a triangle that's very close to 0 degrees first, right, we see this B value. It's not a good triangle. Right, we see this B value is very close to the C value, adjacent of our hypotenuse, B over C. Right, and when it's a flat triangle at 0 degrees, right, the B and the C value are going to be essentially the same. So it's kind of like a reverse sine situation happening. Right? Sine of 80 degrees was 0.985. So cosine of 10 degrees is going to be the same thing. This will also be 0.985. Right? 70 is complementary with 20 degrees. So sine of 70 equals cosine of 20. So sine of 70 is 0.94. Then cosine of 20 is 0.94. And we can keep repeating. Right? And by the way, sine of 60 degrees, we should know the exact value for this. This is radical 3 over 2, right, which is approximately equal to 0.866 from our special right triangles. And cosine of 30, also radical 3 over 2. 50 and 40, this will be 0.766, 0.64, 0.5, 0.342, 0.174, and see if we can make sense of cosine of 90 being 0, right? The B value is going to be pretty much 0 at that point, and so there we go. Those are the values we're going to be getting. And let's take a look at tangent next. So what's happening with tangent? Tangent is opposite over adjacent. So in any of these triangles, it's going to be opposite over adjacent, or A over B. So tan of an angle is going to equal A over B. So what's happening is A is increasing and B is decreasing. So as this angle increases, if A is increasing and B is decreasing, well, we're going to be dividing an increasingly larger number, right, by an increasingly smaller number. And what that means is tan data is going to just increase, but it's going to increase way faster than sine data. All right, so if you're not sure, let's just take a look. Let's just fill in this table and see the values we got. So hold on, let me type this in as well. I'm going to pull up Desmos and tan of 0 degrees. Boom, that is 0. Alright, and that's because just like with sine, at 0 degrees, the opposite side, right, that's going to be really close to 0 when it's a flat line. Well, when it is a flat line, it is 0, so there is no height. So the opposite side is 0, and it doesn't matter what the adjacent side is. Tangent of 10 degrees is going to be 0.176. Tangent of 20, 0.364. Tangent of 30 is 0.577. Tangent of 40 is 0.839. Tangent of 50, 1.19. Tangent of 60, 1.73. Tangent of 70 is 2.75. Tangent of 80 is 5.67. And tangent of 90, if you type that in, it's going to be undefined in your calculator. So undefined. This value here does not exist. And of course we're going to talk about why in a second. But there's something pretty cool we need to talk about with tangent. Let me just move this stuff away. And erase that. Alright, so tangent is opposite over adjacent. Right? If you take a look at sine and cosine, the numbers don't get bigger than 1. Right? Because sine and cosine are adjacent over hypotenuse and opposite over adjacent. And like in one of the homeworks, we said it can't be more than 1 because the hypotenuse is always going to be bigger than the opposite or the adjacent sides. Right? But tangent, that's opposite over adjacent, and there's no rules about what values those could be. Right? It doesn't always have to be the opposite is bigger than adjacent or adjacent's bigger than the opposite. It depends on the angle. So this just keeps increasing. And at like a really big angle, right, you can see the opposite side to data, this length, right, that's pretty big, and this length is really small. So what's happening at 90 degrees? Well, when we get to 90 degrees, the opposite side is virtually the same thing as the hypotenuse. It's very, very big, right? And then we're dividing by a teeny, teeny, tiny number, which gives us a very big number. And at 90 degrees, we're essentially a vertical line. Well, at 90 degrees, we are a vertical line, which means this b value is 0, right? And we know when we divide by 0, that's undefined. So something that's pretty cool is that if you take 0.174 and divide it by 0.985, you're going to get that value. If you take 0.342 and divide by 0.94, you're going to get that value. And that is because tangent of theta is also equal to sine of theta divided by cosine of theta. Alright, if you want a super quick proof of that, tangent of theta is equal to, well, I know sine theta is opposite over the hypotenuse, right? So I just replace sine data with opposite over hypotenuse. And I know cosine data is adjacent over hypotenuse. Well, I have a fraction divided by a fraction, so I can change division to multiplication by the reciprocal. So I can change that to opposite over hypotenuse times hypotenuse over adjacent. And just like that, we have opposite over adjacent. So tangent of data is equal to sine data over cosine data, because sine data over cosine data is that. And simplifying that, we get the definition of tangent, opposite over adjacent, right? So katoa. And that's exactly what we see here. So yeah, pretty cool. We can also see that in this graph, because let's just make this easy. If we made the hypotenuse equal to 1, right, do you guys all agree that sine of theta now would be opposite over hypotenuse? And the hypotenuse is just 1, so a over 1 is a. Right, cosine of theta would equal adjacent over hypotenuse, or just b over 1, or just b. And tangent of theta is opposite over adjacent, and that's a over b. Right, but a is sine theta, and b is cosine theta. So tan theta is just sine theta over cosine theta. Right, and this would still work with whatever radius. Right, I just made it 1 to make it easy to see. Right, cool. Alright, so those are our trig values, and hopefully some of it made sense about why the sine value is increasing and this cosine value is decreasing, and what's happening with the tangent value. Alright, so now that we got all of that, let's solve some problems. Alright, make sure you have your calculator, because you need to practice typing them in, of course, and using it. So number 1 here, given right triangle ABC with hypotenuse AB, measure of angle A is 55, find AC and BC to the nearest hundredth. Alright, so before with right triangles, we are finding the missing lengths using special right triangles, like a 30, 60, 90, or 45, 45, 90. Well, this is not a special right triangle, so we're going to have to rely on trig values. So let's say I'm looking for BC first. I'm going to call that X. So this is a right triangle, so I can use trig. And we have this angle. We also have angle B, by the way. We can solve for that. But using angle A, well, what sides do I have in relation to angle A? In relation to angle A, I have the opposite side, right? And I have, this is not the adjacent side, but that's the hypotenuse. I have the hypotenuse across from the right angle. So let's think which trig function involves the opposite, right, and the hypotenuse. So if I think Ferrero Sokatoa, opposite and hypotenuse is going to be sine. So I'm going to use my sine trig function. So I can say sine of A, angle A, or 55 degrees, is equal to opposite x over the hypotenuse 8.5. So solving for x here, I just need to multiply both sides by 8.5. So 8.5 times sine of 55 degrees is equal to x. Well, what is sine of 55? You type that into your calculator, and that's how you get the sine of 55. So trig, button next to 7 of 55. Again, make sure you are in degree mode. That's equal to 0.819152. Right, you don't have to show this work ever. Just for the first one, I'm showing it. So sine of 55 degrees, if we look at our table, by the way, right, 55 degrees, that's right in between 50 and 60 degrees. Isn't that where 0.819 would go? Right, so somewhere in between 0.766 and 0.866. And we're going to get times 8.5. What did it tell us to round to? To the nearest hundredth. That's going to be 6.96 approximately. Alright, when you type this into your calculator, you do not want to type this in, right? Just type that into your calculator and get your answer right away. And so now if you want to find the other side length, AC, let's call that y. And now again, let's think about what trig function I can use. If I'm using angle A, well, y is the adjacent side, right? 8.5 is still the hypotenuse. So I have adjacent and hypotenuse. I'm going to be using my cosine function. So I can say cosine of 55 degrees is adjacent, y, over hypotenuse, 8.5. Right, y is going to equal 8.5 times cosine of 55. And let me type that in. Times trig cosine 55. And that's going to be approximately 4.88. Did it give us units? No. Alright, next. The bus drops you off at a corner of H Street and 1st Street, approximately 300 feet from school. Alright, so we're getting dropped off right here. You plan to walk to your friend Janice's house after school to work on a project. Approximately how many feet will you have to walk from school to Janice's house? Alright, so that's 300 feet to school. How far is it from school to your friend Janice's house? So we're going to simplify things and assume that this leg of the triangle is the distance, right? That distance is 300 feet. And yeah, so we're just solving for this leg. Well, sorry, not the leg. This is the hypotenuse. So if this is 41 degrees, let's think about what trig function we're going to be using again. All right, so we have the opposite side length, and we want to find the hypotenuse. So I want a trig function that involves opposite and hypotenuse, which is sine. So I can say sine of 41 equals the opposite 300 over the hypotenuse. And so solving for the hypotenuse, I get the hypotenuse. I don't know why I'm calling it hypotenuse. Let me just call it x. So we get the hypotenuse x times sine of 45 when I cross multiply equals 300. So solving for this one, it's a little different. We're going to divide by sine of 41 degrees, and that's going to give us the length of x. So 300 divided by trig sine 41, and that's 457 feet approximately after rounding. Right, and when you do these problems, just do a very quick logic check. All right, this is a hypotenuse, so this better be more than 300 feet. If you're getting an answer like 900 feet, that's like way too big, right? The angle would have to be very, very big for 900 feet. If you're getting an answer less than 300, that obviously can't be the case if that's a hypotenuse. So just check to see if your answer makes intuitive sense, or like, yeah, that's all. Right? Here is a little nicer problem. Right, Joanna borrowed some tools from a friend so that she could precisely but not exactly measure the corner space in her backyard to plant some veggies. She wants to build a fence to prevent her dog from digging up the seeds that she plants. Joanna returned the tools to her friend before making the most important measurement, the one that would give the length of the fence. So she decides to use the Pythagorean theorem to find the length of the fence. Is the Pythagorean theorem applicable in this situation? Explain. Alright, so she tried to use the Pythagorean theorem. Can she use it? The answer is no, because this is not a right triangle, right? If that were a right angle, that would be the hypotenuse, and that's fine. So we cannot use Pythagorean theorem here. So how can we find the length of this fence? Well, we need to make right triangles. So I think this is a good problem to try. This is probably a question I would have asked you to turn and talk to your neighbor for a couple minutes, right, to work with someone. So if you want to try this now, it would be a great idea if you paused it. All right, but moving forward, we need right triangles. So what we could do is drop an altitude, and we get two right triangles here. And I'm looking for this entire distance, but I could break this up into two right triangle trig problems. There's one, here's another, right? And in each triangle we have an angle measure and the hypotenuse. We have an angle measure and the hypotenuse, which means we can find the other two lengths in each triangle. So the length of this fence that we're looking for, I can break it up into two parts or two problems. I can call that x, I can call that y, right? And I can find each piece using trig. So if I want to find the length of x, for example, I'm going to use this 35-degree angle. I'm going to be using cosine of 35, right? Because x is the adjacent side, and 100 is the hypotenuse. 100. Right? And by the way, I keep using the angle they give us, but if you want, you can also use this angle here, right? Because that angle is going to be 55 degrees. So we can also say sine of 55 degrees if you use that 55-degree angle, right? This side is now x, right? Sine of 55 is equal to x over 100. You can also use this trig ratio to solve for x, right? And of course this makes sense because 35 and 55 degrees are complementary angles, right? And we know the sine or cosine of an angle is equal to the sine or cosine of its complement. So that's why these, of course, are equal to the same thing. All right, so I'll let you guys finish this problem up on your own. I'll just post an answer later at the end. All right, but we can set up that ratio to find x, do something similar to find y, add x and y to find the final length of the fence. So lastly, same kind of problems, but sometimes they will throw in this vocab, angle of elevation or angle of depression. Right? If you're looking down at something, that is the angle of depression from a horizontal. So that's your line of sight if you're looking straight forward. If you're looking down at something, this angle here is your angle of depression. If you're looking up at something, you have to elevate your head, right? You have to tilt your head upward. So when you tilt your head upward, that's an angle of elevation. When you're depressed, you're going to be looking down. That's going to be called the angle of depression. All right, so same thing here. A is looking at B. The angle of depression is going to be that. If B is looking at A, this is going to be the angle of elevation. All right. So let's just do one problem with that vocab in it. Standing on the gallery of a lighthouse, the deck at the top of a lighthouse, a person spots a ship at an angle of depression of 20 degrees. So some guy is right over there in the lighthouse, and he spots a ship. Bam, like that. The lighthouse is 28 meters tall and sits on a cliff 45 meters as measured from sea level. So this here is 28, but from the sea level, I'm assuming sea level is here, that distance is 45. And let me just draw this a little better to show just the lighthouse is 28. What is the horizontal distance between the lighthouse and the ship? So if you complete our right triangle here, right, we're looking for this distance. Let's call that x. All right, so there's one thing I didn't label, which is the angle of depression. So a lot of people mess up this and say that's 20 degrees, right? In this case, it clearly doesn't look like 20 degrees, and that might help you, right? But remember, angle of depression, it's from a horizontal. So imagine you're this guy, right? You're in the lighthouse, there's your head, right? When you're looking straight forward, that is what you're seeing. Angle of depression, you're depressed, you're going to be looking down. So when you're looking down, that's the angle you're looking down at. That is your angle of depression. And just want to erase that. So this here is 20 degrees, which means this angle here is 70 degrees. Right? And by alternate interior angles, you can say this is also 20 degrees, or of course 20 plus 70 is 90. They're complementary. Right? And in problems like this, you can always assume that is a right angle. Right? If you have a tree growing out of the ground or a house, you can assume it's a right angle. And what is the horizontal distance between the lighthouse and the ship? So, doesn't matter which angle you use, but let's say I use this angle here, 20 degrees. So which sides do I have with respect to 20 degrees? If I'm using this 20 degree angle, I have the opposite side and I have the adjacent side. I do not have the hypotenuse here. I mean, if you want, you could find the hypotenuses in Pythagorean theorem, but that's extra work, right? I have the opposite and adjacent, so I'm going to be using tangent here, right? I have opposite and adjacent. So I'm going to say tangent of 20 degrees is equal to opposite, which is 45, over adjacent, which is x. And then I can solve for x. So x times tan of 20 equals 45. X equals 45 divided by tangent of 20. And give me 1 second to type that in. Trig tan of 45. Why am I doing tan of 45? Sorry, 45 divided by tangent of 20. And that's going to be about 123.636 round to the... doesn't tell you to round. So, should tell you to round to whatever. But let's just round to the nearest tenth, let's say. And 123.6 meters. Alright. Of course, this is not exact. I should write approximately. And yeah, that's that. So in this problem, they gave you extra information. You did not need to know the lighthouse is 28. It's okay that we didn't use it. But that's it. That is using our trig values. All right. So 2 things you should know from today. Just the general pattern for sine and cosine, right? Tangent less so, but hopefully that part made sense. You should definitely know sine and cosine of 0 and 90 degrees, in addition to our 30, 45, and 60, the exact values of all of those. Right? And how to use these trig functions, right, to solve problems like this. Right? So number 5, that's another problem you can try involving angle of elevation and or depression. And yeah, that's going to be that. Our test is going to be on Monday. If you have any questions about that, let me know. And I will see you guys later. Have a good night.